Well, hello everyone. Let me just make sure my microphone is on, and now it is. Hello everyone. I think I'm almost figuring this thing out here. Welcome to Copernicus FNL Friday night live stream. My name is Drew Desker. I'm the director of Copernicus Observatory, and we're so glad to have you join us today for today's presentation on the Mars 2020 rover Perseverance gets ready to land on Mars. With me on the other side of the screen is Tish, Bresee, our educator here at Copernicus, and as a NASA JPL Solar System Ambassador. And tonight is her night to shine. And so we'll be talking about, she'll be diving into her presentation momentarily. Well, again, we just want to make you aware of a couple more things that are coming down the line here. So today, again, is the talk on Perseverance, the preview. Next Friday, February 12th, Robert Burns from the Copernicus Astronomical Society will do Winter Skies. Robert does a fantastic job of sort of investigating what's out in the night sky here in the winter, and will tell you what's out there, where to find it, and what's interesting about it, a little bit of background on it. So that'll be great. That'll be 7 o'clock next Friday. Then on February 18th, which is a Thursday, and actually Thursday afternoon, starting at 2 o'clock, we will start a live stream of the actual landing of Perseverance. We've got a NASA live feed set up for us to be able to rebroadcast, and then we will provide some color commentary through the YouTube chat. So that'll be Thursday afternoon. If you can find a way to plug into that, that'll be great. And then finally, this is what we got scheduled currently, but I'm working on some additional live streams, is February 19th is our Winter Star Party. Last year we had probably close to 300 people up here. It was outstanding. It was crazy. A lot of fun. Unfortunately, this year we're going to have to do it via the live stream, but we will still have a lot of fun. And we've got at least two programs lined up. First program will be Bob Noya, the former editor of Sky and Telescope magazine, and he'll be doing a talk on the mysterious SETI signal from Proxima Centauri. About 2 years ago, there was the Parkes Observatory out in Australia picked up a narrowband radio signal from the direction of Proxima Centauri, which is only 5 light years away. And so not sure, was it an actual intelligent signal, or maybe it was some kind of human radio interference. But so he'll talk about that, but also he'll talk about if in fact it was the real thing, should we in fact answer the call? And if we do, what do we say, and how do we say it? So that'll be that first talk on the Winter Star Party. And then after Bob's talk, we'll do a little celebration, because February 19th is the actual birth date of Nicholas Copernicus. So we'll sing happy birthday to him. I'll have a cupcake with a candle on it. We'll blow that out, and then we'll transition to an old friend of mine, a friend I've known for a long time, Dr. Linda French, who just retired as a physics professor at Indiana Wesleyan University, and she was. Her main focus of her study was on distant asteroids, and she's calling her talk "Studying Space Rocks with Ground-Based Telescopes." And Dr. French went to school at Cornell, got her PhD there, and she was the teaching assistant of Carl Sagan. So I'm sure we'll hear a couple of Carl stories mixed into her presentation as well. So it'll be a great time, and so mark those dates on your calendar, and hopefully you can join us. So anyway, we are now going to transition to the evening program. We're looking forward to the anticipated successful landing of NASA's and JPL's most current mission to Mars, the Perseverance rover. And Tish, Bresee, has been following that since its inception, and so she's going to bring us up to date with where it is and what we can expect from Perseverance and Ingenuity. And she'll talk more about Ingenuity as well. So Tish, we'll take it over to you. Push it over to you. I'll turn off my microphone and take it away.
Thanks, Drew. Yeah, I know most of us are Carl Sagan lovers in this area. So that's going to be really fun for the Winter Star Party on is that the 19th?
Mhm.
That's the day after Percy lands. Okay. So let's take a look at what we're going to share with you today. I'm going to ask Drew if you see what I have on the screen.
Not
Drew?
yet. Not yet.
Okay, then we're going to have to share that. Whoa. Let's try it again. Okay.
We swear this worked before.
Honestly, what's going on?
There you go. All right, you're in. We're starting to see it, and there we go. Go ahead.
And we've got sound. Okay, thank you. Let's see, we're going to start.
And it was requested if you could try to speak up maybe just a little bit more. Thanks.
Okie dokie. So I want to thank a lot of people for all the information that they helped us out with. I am a solar system ambassador, which means that NASA sends me materials and information, and I pass it along to you. There's probably about 300 of us in the whole country who work together and separately to do all kinds of presentations, but this is one that we all promised the Jet Propulsion Lab we would help them out with, because COVID has made life difficult for all of us to communicate what's happening in space and everywhere else. So let's see if we can help each other by spreading the word around, and I'll show you some really neat websites where you can share the information and dig a little further. So Perseverance, we'll call Percy today, is the big brother of all the other rovers, and we're going to see what's going on as it gets ready to land. February 18th. Before I start this up, let's say hi to Jim Bell. He did a presentation for me last week and told me some really interesting secrets about Mars. He's a geologist, but that's not really the right word when you're talking about Mars. Can you see me in this? I can't see myself on screen.
Yep.
Drew, can you see me?
Yes, I can. I'll lift it up maybe a little bit closer to your face.
Okay.
A little higher, because I only see half of the words there. Yep.
Jim wrote this book about the Hubble and its 30 years in space, and it's such a beautiful book I have to show you. Hubble's legacy is just about come to an end, and I just wanted to mention that this book is awesome. You can get it now at Amazon and everywhere else you buy books. Jim is a geologist. He's an expert on rock, and what we're looking for with Percy is sedimentary rocks that are 4 billion years old. We don't have any on this planet really that we can find. And if there is a fossil of any kind, it might be there. I also want to make sure that we say thanks to Sarah Marcotte from the Jet Propulsion Lab. She is in charge of making sure all the educators get everything they need. And this year, NASA's warehouses are all closed, so they cannot pass out new equipment, new stickers, new bookmarks. You're going to have to come up when we all get our vaccine, and someday when you come back to Copernic, you'll see a Mars sticker for you waiting. But right now, Sarah's job is very difficult, making sure that all the solar system ambassadors and other people who help out have all the information we need. So thanks a lot, Sarah. She lives over in Pasadena, and life is good there. Alan Chen is another person I want to thank. He designed an interesting piece of hardware that's on Perseverance. It helps it land, and I'm going to show you about that. He did a presentation for all of us solar system ambassadors, and he's a really cool guy. He loves Elvis for some reason. He puts Elvis stickers on all of his work. A couple of mysteries about that. So we really want to thank them and all the other wonderful scientists who, probably thousands, that work on this project. What is going on? Let's just take a peek at the website. And first I'm going to share the website. I don't know why my face wasn't showing in that picture, Drew. I've got to figure that out. But this time I want you to see.
Yep, we did see it. I just you just couldn't see it.
Oh, okay. Well, that's cool. This one I think is the one I want you to see. Yeah, this one. Okay. I'm going to share this right here. Okay. Can you see where is Perseverance?
Yep.
Let's try that.
Yes, we can. We see the quick backs.
All right. Now. Okay. Yep, this is the one I want. Okay, can you see it?
Yes.
All right, so this is what the website, the home website, looks like here at JPL's Perseverance site. And I want you to be able to write this down. This is a really easy one. mars.nasa.gov/Mars 2020. That's Percy's other name, Mars 2020. And if you click through these slides, this is the one that tells you where it is and how far away it is. Right now it's 277 million miles from Earth. That's why it took 8 months, about 8 months to get there. And it's 94% of the trip. A little bit more to go till February 18th. Then I'm going to click back. This is one of the coolest inventions that help us find our way to the right spot on the planet. And you'll see lots of things you can click through, like how this carriage works that helps it land. Here's our countdown, 12 days left, 20 hours, 40 minutes, 38 seconds, and so on. You can watch a trailer when you go to this one. And you can even get your name sent to Mars. Not on this one because he's already on his way, but on the next rover, you can get your name and you can get a boarding pass. That doesn't mean you fly with it, but your name flies with them. So take a look at all the cool pages on that website. There we go. Let's go back to where we were, and I will show you some cool stuff about Mars. You know what? This is not working there. Let's do that. Okay. Let's share that. Okay. Switching back and forth isn't easy, so thanks a lot for your patience. There we go. Now I can actually see myself. Okay, so you saw the website, mars.nasa.gov/Mars 2020. That's really easy. That's the first one we'd like you to learn and use it often. Let's move on. This is a theme song from The Martian called Making Water. Do you think water has something to do with why we are traveling to Mars? Do you think water is important in your life? Well, right now we are testing some ways to get there and farther out in space. Let's see if the sound works on this. Can you hear it?
Yep, we're good.
Great. NASA is exploring all around, from the moon to Mars and beyond. will be landing on the moon, but first we're going to be sending equipment. Because you want to have a house there before you arrive. Working with SpaceX on this. We want the people to be comfortable. Then we go to Mars. There's a little glimpse of Bresee. Animation. And we're hoping that the James Webb Telescope will be ready to go probably by September. Take the place of the Hubble eventually, and it'll be all times together. The station will stay up in space for training.
3, 2, 1, 0. Ignition.
I want to mention that Northrop Grumman has a launch order tomorrow at 12:30 from the Virginia site. People who are about 7 or 8 years old are going to be just the right age to go to Mars. When we're ready, it'll be 20 years. Okay, let's move on. So here's the whole procedure. This is the outline of what we expect from the Earth to Mars. The path will be like from the space station to the Space Launch System, stopping off at the moon on the way, and then delivering to Mars. But remember, it's only every 2 years. I'll show you about that. The missions are spaced out like this. These are all the ones that are going on right now, and many future spacecraft. All right, where are we going? Well, let's take a look at this map, huh? Can you find the very first rover? Let's see. It's called Pathfinder. Pathfinder had wheels, but it was really small. I'm going to point to it for you. It got stuck against a rock, and it's still there, stuck. We learned to make rovers bigger from Pathfinder. Of course, Viking 1 and Viking 2 landed, and they are still where they landed. Phoenix is covered with snow probably by now. It's way up there near the North Pole, but it showed us there's quite a bit of ice that you can actually melt and drink. The water kind of ice. Then we've got Spirit and Opportunity. Notice that they are near the equator. This is the equator, the warmest part. And so, let me go back to that. And Jezero Crater, that's our location for Bresee to land. And we'll get a close look at that in a little bit. But you can see that there's an area here of flat, this is an elevation map. That's not water, but it looks like water. Anyway, this is the low elevation of the delta. Jezero Crater's right here. This is where we're aiming for. I want to point out that InSight is a digger and also has a seismic device, so it can measure when there's Mars quakes on the planet. It's not too far from this volcano, so there's a pretty good chance InSight will catch something. And what else did I forget? Oh, Curiosity, of course. She's still there. She's still roving around. She's doing a good job. She landed in 2012, and she's right near the equator. She actually saw when InSight landed. She looked up in the air and said, "Hey, what is that? I've got a neighbor." But they're pretty far away from each other. They only go a little bit every day. I should say Curiosity only goes a little bit every day. InSight doesn't have wheels. So the two red ones, Jezero and Oxia, are locations where we were thinking about landing, and we chose Jezero, and I'll show you why in a bit. Between Bresee and ExoMars, they're going to hand off tubes of rock and stone, and they're going to lay them down on the surface, and they'll be picked up by another rover and blasted off into space to bring them back home to Earth for our scientists to explore. Maybe you could grow up to be a scientist that explores that first rock from Mars. All right, let's see. Yeah, that's pretty good. So the highest places are white. Here's the three mountains. They're all volcanoes. And then the largest volcano in the whole solar system, do you know what it is? Say it to yourself. Olympus Mons, right? 17 miles high. So the red and the white is very highland. And the green and blue are lowlands. Places that are safer to land. If you don't want to land on the edge of a crater and fall in, okay, that would be bad. Okay, so I'd like you to study maps like this. You know, at Copernic, we have one that is 25 feet long. It's bigger than a room. And you'll be able to work the robots around the map and learn about Mars when we do finally get back to working at Copernic. So watch for that giant Mars map we have. It's going to be awesome. Okay. Someone asked me about what ExoMars looks like. Let me see if I can find it. Can you see that? I will stop sharing that and start sharing that. Okay. This is what ExoMars looks like. Can you see it?
Yep. Yep, we can.
Okay. It's very simple. It's not a real complex rover. It's got small wheels and a solar panel, which, you know, just folds right up like a book. But it also has a mast headgear that is just about 6 feet high. Not as tall as Mr. Desker, but taller than me. And you can look around with your camera. And this was meant to go around and find the cylinders that Bresee leaves behind. The rock is going to be saved in a container and then sent back to Earth for examination. So ExoMars will be part of this relay race to learn more about the rocks. Okay, let's go back to, I could just push new share, couldn't I? Okay, let's share that. That didn't work. Okay.
Also, Tish, just we got some input that when you played that other video, the music was so present that we really couldn't hear you. So if you get another video like that, just let it play out, and then you can make your comments after that.
And I think I can turn it down too. I will try to do that.
All right, just wanted to let you know.
Okay, thank you. Okay. Let's see if I can react to where I'm supposed to be. Do. Share that. Okay. Okay. So, what do you know about Mars? Well, it looks like a big round dirt ball. It's more like cinnamon colored. So get out the cinnamon out of the cupboard in the kitchen and notice that it's orangish, brownish red. It looks red to us from millions of miles away, but it's really orangish, brownish red. And it's so dusty and dry that the wind blows it away. But you know, it's not very windy. If you try this, put your hand in front of your face and blow on it just a little bit. That's about a hurricane on Mars. It doesn't bother you at all. Don't believe the movies that show wind and terrible things being blown at you. It's not like in the movie The Martian at all. The wind is not strong enough because it's 1/100th of the atmosphere, 1/3 of the gravity because it's a small planet, 1/100th of the air pressure, and negative 150 degrees. That's the coldest end probably, although I've seen a 200 before, but we're going to be near the equator most of the time, and it gets down to 150 below at night in the winter. But you know what? During the day, on a summery day on Mars, it could get all the way up to 50 degrees Fahrenheit, so that's not that bad. The problem is that you can't breathe the air, so you still have to have your spacesuit on. Now, we have something on Bresee that will maybe help that. It'll get rid of the C in the CO2. What does C stand for? Let's think about that. What do you think it is? Right, it's carbon. The carbon is the problem. We don't breathe carbon very well. We breathe oxygen and nitrogen most of the time. So we bring some nitrogen with us, and we use the separator called, see if I can show it. Oh, it's not on this page. It's called MOXIE. I'm going to show you what MOXIE does. Now, let's pretend that you're flying over in the Mars Reconnaissance Orbiter, and you're looking down at the planet, and if you look up in the top left, you can see time go by. It says the million-year line, and then it says summer. Okay, so it goes from spring to summer and back again. This is a GIF, so it's going to keep repeating. What is happening here? Can you see water? It's flowing down from my right to left, right to left. But what happens to it when it reaches that very, very thin air? It evaporates. If that's what you said, you're right. It evaporates so quickly that the water doesn't have a chance to moisten the ground much at all. But it's usually underneath the surface. So imagine if you could take a shovel and dig a little bit on Mars. Underneath you'll see some ice, but it will evaporate pretty quickly in just a couple minutes. Maybe there's some way you could save it and use it for water. Okay, so there's CO2 ice and then there's H2O ice. We want both kinds, I think. Mostly H2O. Let's move on. I want to thank Alan Chen for this clip here. This is a simulation of the new landing technique that Alan came up with. And instead of landing in the wrong place, it will hesitate for just a moment and examine the surface and figure out if that's a safe place. And if it isn't, then sends the jetpack over a different direction. So it compares it to the map in the computer, takes lots of pictures, and decides where to land. So this will be a lot more precise on where we can land with Bresee. Up until now, we've been pretty lucky, but a lot of the missions have crashed. I'm going to show you a list of the missions in a few minutes. There is a...
Actually, Tish, I was going to just mention that when we had Nagi Cox up talking about Curiosity, she had mentioned that the initials JPL not only stands for Jet Propulsion Laboratory, it also stands for Just Plain Lucky. They've been fortunate that all of their missions have been successful, at least to Mars. So, anyway, I thought I'd share that with you.
Oh, that's nice. I'll bet the other countries are really angry with us because we get a lot more than they do, but we've made our mistakes in the past. Notice this website here. This is the simple one to find out more about Mars. Real simple. And then this long one at the bottom, it says hear audio from NASA's Perseverance. Just Google that, audio from NASA's Perseverance. I'm going to show you that it comes with microphones, and right now all you can hear is whooshing noises because it's in space. And but you can go and listen to the whooshing noises if you want. But when it gets closer, you're going to hear more things happening. Like when the carriage drops the spacecraft, you'll hear the pyros pop, and they are electronic fireballs that cut the rope and drop it on the ground, hopefully, straight up. There'll be lots of cool noises you can check out. So it's called Hear Audio from NASA's Perseverance, and it'll be fun. We can listen to her all the time. Or is it he? Is Percy going to be a boy? I want you to think about that. So let's get to know the spacecraft itself, and I'm going to go here first. And I'm going to save that one for you guys. It takes a second for it to work. Let me see, I'm going to stop that and start that. And stop. I can't see the share button. Drew, there it is. There it is. Okay, good. It took that long for it to load. Just a few seconds, you'll see it load. This is the Perseverance 3D simulator, and you'll see it at nasa.gov Mars 2020. And you can grab it and move it around. You can see the underbelly. That's where Ingenuity is, that little helicopter. All right. And you can see that the tires are so much stronger than Curiosity's. They're at least twice as thick with the aluminum here and with the titanium here. Aluminum and titanium wheels, and they're twice as strong at least. But let's rotate it around just to show you one thing. Let's see, what's the one thing I wanted to show you first? Well, Sherlock is amazing. Let's get close. And Sherlock has a drill, 2 drills actually, and it takes the sample and drops it into a container. You're going to see that in the next simulator. And it will be saved in a cylinder. And we'll drop it off for the next rover to pick up. Okay, let's go to the cam. Oh yeah, up here there is a microphone so that we can hear what's happening on Mars. You know, maybe there's something cool that I haven't heard before. We have 3 different antennas. This is a UHF. Drew's an expert on radio antennas, so he could tell you more than me. This is a high gain antenna, making sure that the pictures and everything are sent to, they've actually bounced them off the Mars Reconnaissance Orbiter, which is going around the planet. And well, there are 27 cameras, lots of them. It's an amazing thing. These 2 rods here are for doing the weather report, finding out what the weather's like. Very exciting. Oh, and I really want to mention this. This tail is just like Curiosity's. There's about a 20-inch rod of plutonium that gives her or him the energy that they need, even at nighttime. So that's very exciting. That was a smart move because Mars is not as bright. You know, it's much farther away from the sun, so you don't get so much sunshine. So have fun with this. This has got the whole list of all the parts, and you can play with this at mars.nasa.gov/Mars2020. Okay, let's go back. How do I do this? Okay. Do this. Resume. No, I don't want that one. I want this one. Okay, stop that one. This is. Thank you for your patience. Okay, so details about the trip. Let's see what's going on. Can you hear that? Can you hear it?
Yeah, we can. We just need to, don't, I would say don't talk that.
Okay, remember Bresee's hometown is Pasadena, California. So a lot of the times they're going to give you are going to be Pacific times. Let's be careful you don't miss the landing. All right. So that was a pretty interesting simulation of the whole landing. Let's take a look at the next one. And here's the whole picture. The beautiful big brother of Curiosity, very similar but also really strong and bigger. More tools. You've got to have an X-ray spectrometer if you want to look right inside to see what it's made of, whatever you're looking at. Here's the Moxie. It produces oxygen from Martian CO2 right inside. Let's see what Ingenuity's up to. It's sort of like Reminds me of giving birth, because Percy's gonna drop it off of its belly and see if it can fly. Let's see. Here we go. If you can hear me, think about why it has so many propeller blades. Ingenuity does not live on plutonium. What does it use for energy? Did you see the solar panel? You're right. But it does have batteries. Got it, so it can take pictures. Do you see an advantage there of going up high to look around the neighborhood? And it looks like Percy's following up with the camera. Those super light legs are made of carbon steel, and you can see that those double propellers will help it get around much better in that 100th air pressure. Okay. So, what's the advantage of being able to look around? Well, do you guys remember Spirit? What happened to Spirit? I'm going to let you think about it while I go to the next page. Remember what happened to Spirit? Well, she got stuck, right? And if she had some way of looking around the neighborhood from high up, she could see that there was something up ahead of her with a really deep pile of sand that she couldn't get out. It would have helped us a lot. Didn't I just show that?
Yes, you did.
Okay. Okay. Moving ahead. This one is more interesting to me because it shows the inside of the spacecraft. Let's take a look. Let's say Percy found a really nice looking rock with its spectrometer. Warm up, Sherlock. Get ready to drill. the drill puts the sample in a cylinder, puts a top on it, and there's a round carrier that moves it into storage. Let's see what it does inside. Now you know the engineers have practiced this a lot, but it has to go through several steps. Measure the volume, seal the tube, image it at every step, and move the tube to storage. And then it's going to dump all the tubes in a pre-designed location. I don't know what it's going to be. And the next rover is going to pick it up and send it home. Pretty sharp, huh? So what are we looking for? We're looking for any sign of life, right? So this one is different than Curiosity. Curiosity crushed everything to see if it had molecular hope of what we needed. But this one is going to keep the chunks together, and we're going to send that back home so we can find out if there are any fossils in there. So instead of crushing it, we're going to keep it whole if we can. Okay, let's move ahead. Compared to Curiosity, look at her. She's been there since 2012. What do you see? Look over here. Aside from the square holes, there are other little holes that we did not expect. Combination of poisonous soil and very, very cold temperatures can make it crack. Even aluminum can crack. And does anyone notice something weird about this? There is no pointy tube on the body of Curiosity. What is that? Are you thinking about it? Well, what they did was, in order to take this selfie, we had to first take lots of pictures, and the only way she could take pictures of herself was to use the arm. So then they had to erase the arm. So the arm would be in the way right here, right? With all those tools on it. So they chopped it off with a camera. It's still there. It's just got erased digitally, I guess. So don't worry about Curiosity. She's still got an arm. It's just chopped off for a little while. All right. Now, she's still going to be working in her area, looking for dust and sediment. She found some great clay, which told us that there were definitely some watery places where she is. Look at those rocks. All the layers, that's definitely water. Signs of water. So hang in there, Curiosity. We've got your big brother coming. All right, so if we go back to 1997, the Sojourner landed, and that was the one with the little rover that got stuck. Then Spirit and Opportunity came in 2003, and boy, they did a wonderful job, didn't they? They lasted over 10 years. Now Curiosity is working, and Mars 2020 will be arriving soon. The whole launch and landing outline I want to share with you for a moment. Let's see. Oops, wrong one. Sorry. There it is. Can you see this? Start
No,
the
no, we still see your Explorer. You want to minimize that? And then, or stop sharing and go to the one you want.
Sorry. Okay. Let's go to the right one. That one. Okay. Looks a lot alike. Okay. The chronology of Mars exploration is kind of fascinating because if you look carefully, you see launch failure, attempted Mars flyby, attempted this and that. They didn't make it, contact lost. Dr. Fowler told me that the Chinese sent up one that crashed. It was going to go to Phobos, one of the moons, and it crashed here on Earth. It had tardigrades inside. And I'm looking at the ones, let's find the Chinese, okay. These are Russian flags before 1989. Looking for Chinese. Okay, the Ying Hao, no,
Right.
yeah, that might be it.
Yeah, that's it.
2011. Anyway, we were thinking, what happened to the tardigrades if they crashed in space? They might be having a party somewhere on another planet. They can survive almost anything. Okay, but that was fun, a fun thought. So you can see the ones that America did, most of them made it, but not all of them. And why are there so many spaces between them? Especially right here. Look at that, in the 70s and 80s. We had some accidents here at NASA. And because of that, the Challenger and so on, people were afraid to fly and afraid that something was wrong. So everything had to be checked and rechecked, and then finally we got back out there. But this is where we are now. You'll find this list at nasa.gov, planetary chronology. Oh, I wanted to mention this right here. Do you see 3 in a row for 2020? Oh, that's not going to be highlighted. Okay. Hope, July 19th, left the Earth for the United Arab Emirates to be an orbiter. And so it's on its way at the same time as Perseverance. And then there's Genuine. I don't know if I'm pronouncing that correctly, but they left July 23rd, and they have a rover and an orbiter, the Chinese do, and they're kind of new to this. They did a good job of landing on the moon a couple years ago, but I don't know about Mars. We'll see if it makes it. So I think we just have to stay away from those other two. But we should keep our eye on them, right? We'll find out what happens with them too. Please feel free to share this information and compare it with our own rover and see who's going to be first on Mars, who's going to be second, who's going to be third, who's not going to make it. All right. Then much later, we're going to be going back to get the samples. Okay, now I'm going to switch back to my program. And yeah, we are. Okay. Okay, please see us on Twitter, Instagram, Facebook, Google Plus, YouTube. That's Copernic YouTube, please. You'll see us there. And Drew is going to talk to you more about how you can do the live streaming broadcast with us on the 18th. I'm going to show you a couple more pictures and then I'm going to see if there are any questions. Can you see the ripples in the sand? These are special images set aside by the Mars Reconnaissance Orbiter for you, just so you can see how beautiful Mars is. The white is mostly frost, and the blue is mostly sand. You can see the wind has been blowing the sand and the frost. Here's a really neat one. Look, notice the name here. Perseverance Valley. Poor opportunity. She couldn't get any further. Endeavor Crater and Perseverance Valley. That's a good name. And dust devils. Curlicues are made by the wind and the scraping off the surface. The surface frost is removed, and what's underneath is a darker soil. Kind of neat. And here's beautiful Jezero Crater. You got to see the big map to really appreciate this, but this is where the water comes in. And this is where the lake was. Can you see the delta? That beautiful delta. You can see the soil has settled here. What they did was they used artificial coloring with this spectrometer. They wanted to label the mineral content 3 different colors. So they used green for one mineral, and purple for another one, and blue for a third. We think they'd like to land here. Where would you go? Where would you want to land? A mountainous, bumpy place or a really flat place? A place where maybe water was a long time ago? We're thinking 4 billion years ago. Or a whoosh right here. If you look further on the big map, you'll see that the water actually flows out as well. Now that's old water. That's water that's evaporated over time. Okay. So we'll see you on February 18th. This is to watch the landing. I have a little bit of time for questions. And if you'd like to listen, there's a blog from the nice people at Public Broadcasting. And this is the website, which you can write down if you want to hear the whole thing yourself, where 3 wonderful scientists, all ladies, are going to talk about Mars. Okay, Drew?
Yeah, we do have a few questions.
All right.
So, first question from Linda was, where did that picture of Mars come from?
The big one?
Yeah.
The big round ball?
Do you recall whether, is that an artist conception or was that actually an actual image?
It's a Hubble photograph. Wait a minute.
No. It's where you're sort of like almost there. You know, you could sort of see the big round part of it.
That's Mars Reconnaissance Orbiter.
Oh, okay. Very cool. Very cool. All right. Nicholas asks, can all the wheels drive the rover? Is it a 6-wheel drive rover? Do you know?
Yes. It can get itself out of a lot of trouble.
So each wheel has its own
Each individual wheel
has its own motor.
Yep.
All wheel
And camera.
and camera on top of that. Wow, cool. So you can really get down and see what's causing your problem. Nice.
Yep.
Philip has a couple of good questions. He wanted to know, does Ingenuity fly by AI, by artificial intelligence? What's flying Ingenuity?
I don't know. I know that Perseverance has a transmitter. Do you think that radio transmitter would do it? You know more about radio.
My guess is it's much like Curiosity or any of the rovers, that they basically have to sort of send up a pre-programmed set of instructions as to what to do. Now, there probably is some programming in there to say, all right, let's see what I see from sensors or other images, and then make appropriate changes, if you will. But
I remember it started off with something simple to start, just for a test.
Right, and I understand that actually Ingenuity was a relatively recent addition. They actually sort of had some space, and the engineers came up with that rover pretty quickly. Another question Philip asked was, do you know why the water evaporated?
Yeah, remember we were talking about the air is 1/100th of the density of the Earth's air, so the air pressure and the air amount, the amount of molecules in the air is very thin.
Mm-hmm.
So because it's so thin, it evaporates quickly. It's sort of like, you go to the top of a mountain and you try to boil water, you're not going to be able to do it the same amount of time. Actually, it would boil faster, wouldn't it?
Right.
Okay, at the top of a mountain, it would boil faster.
Less pressure,
The
yeah.
air is thinner up there.
Right.
Same idea.
Right. One thing I was going to actually comment on, last year we did a talk about geocaching. And believe it or not, for those geocachers out there, there's a geocache on Perseverance. It's called, yeah, and it's actually, there is a calibration tray, if you will, with various colors. And one of the areas on that tray is a code that is part of a geocache. So any of you geocachers out there, again, we did this talk about geocaching last year. So if you want to go back to our YouTube channel, you can check that out. And you'll be able to, I guess once Perseverance finally lands, then you can finally actually get that information and log that geocache. So anyway, well, this is great. I'm sorry, go ahead.
I was thinking there is right here, there's a sundial, a circular sundial.
Yep.
It tells them where the sun is, but it also has like circles that are all different colors.
Right. That's most likely. If there's only one calibration plate, then that would be where it is.
Right. Okay.
All right. But so you can check that out if you're a geocacher, or if you want to check out what geocaching is, check out our live stream from last year, and we'll have another talk about that at some point. All right. Well, Denise has a question. Do you know what precautions are being taken when the samples are brought back to Earth and examined?
Oh, I went into one of the labs at the Goddard Space Flight Center where they were handling both moon rocks and meteorites,
Mm-hmm.
and crushing them. They go through all kinds of torture. First, they check it to see if the outside has anything, and if it doesn't, then they crush it to see what the molecular structure is. But I think in this case, they hope to get lots and lots of samples so that they can do anything they want.
Right, but I think ultimately what they're going to do is something similar to what they did with the moon rocks, that they were put into a system so that no gases, nothing can really escape from it until they can examine it with equipment inside the containment area, and then determine what it's finally able to do. Now, what's interesting is also, I'm sorry?
They told us that the moon rock has never touched air or water. Go ahead.
What I was going to say was that now President Biden requested and got from NASA a moon rock, and a moon rock sits in the Oval Office, sort of as a inspiration for going after some challenging things. So that's sort of nice. All right. Well, I think that mostly covers.
That's on the 18th, though.
Yeah, covers our questions here. So I thank you, Tish, for your time talking about Perseverance. We really look forward to the 18th when we actually do our landing party. So we'll put out information on that, and also make sure that you check out our Winter Star Party on February 19th. Also, Copernic's birthday, and also again. So if you're also new to our channel, make sure you subscribe so that you get notified when we go live. And again, if you really enjoyed what you're doing, what we were doing, and value what we do, if you are in a position to, you can offer a donation, to us for these live streams. It helps, keeps the windows open and keeps Tish and I employed. So thanks again for your time. We look forward to seeing you soon, and stay safe. Wear the mask.
Thank you.
Take care now.